Alright, good evening, people. Once again, we will start from programming today. Reading some programming. To be more specific, where are we? Yep, we completed this article. Now we are supposed to write this article. Did I share my screen? Yes, I did. Each variable in C has an associated. Oh my god, this ad is eating me. Each variable in C has an associated data type. It specifies the type of data that the variable can store, like integer, character, floating, double, etc. Okay, data type stores the type of data. Basic things. C is a statically typed language where each variable's type must be specified as a declaration, and once specified, it cannot be changed. That is what you mean by statically typed language. I see. And now, basic data types are int, float, double character, boolean, and void. Okay. Derived data types are array, pointer, and function. Function is a derived data type. I have no idea that. Void main, union, structure, enum. So, is this like a code editor you can use? Okay. Obviously, this is not as fast as a native compiler that you have, but still, they provided you with some code editor, and that's a good thing. I mean, embedded in a web page, that's awesome. Integer data type stores whole numbers, positive, negative, or zero. We use int keyword to declare the integer variable. Size is 4 bytes and range is blah blah blah. Format specifiers %d. Format specifiers are the symbols that are used for printing and scanning values of given data types. Okay, character data type stores a single character, size 1 byte. So the format specifier is %c. That's nice. Float data type stores decimal numbers. Numbers is fractional part. Okay, %f. Double data type lf. So yeah, obviously float and double, kind of like long float, right? Exactly. Stores decimal numbers with more precision than float. Void data type. So long is different. All right. Void greater represents no value or empty type used in functions that do not return any value. Can also be used for generic pointers in memory operations. Yes, we read that a lot in operating systems. Void greet, print a hello world, int main greet return 0. Hello, welcome. Size of data types in C. The size of the data types in C is dependent on the size of the architecture, so we cannot define the universal size of the data types for that. C language provides a size of operator to check the size of data types. Okay, it is dependent on the architecture, but they kind of make us memorize the size of data types. Literals in C, literals are constant values raised into variables that represent fixed value that cannot be changed. Literals are key by memory but do not have references like variables. Often the terms constants and literals are used interchangeably. Type conversion and C type conversion is a process of changing one data type into another. They can happen automatically by the compiler or manually by a programmer. Type conversion is only performed between data types where such conversion is possible. 507 likes. A variable in is a named piece of memory which is used to store data and access it whenever required. It allows us to use the memory without having to memorize the exact address. To create a variable in C, we have to specify a name and the type of the data it is going to store. C provides different data types it can store almost all kinds of data. For example, int, char, float, double, etc. Every variable must be declared before it is used. We can also declare multiple variables of same data in a single statement by separating them by commas. Okay, it was not written here, but yeah, you can write like int a comma b comma c. Rules for naming variables in C. We can assign any name to a C variable as long as it follows the following rules. The variable must only contain letters, digits, and underscores. It must start with an alphabet or an underscore only. It cannot start with a digit. No white spaces are allowed within the variable name. A variable must not be any reserved word or keyword. The name must be unique in the program. Once a variable is declared, we can store the useful values in it. The first value we store is called initial value, and the process is called initialization. It is done using assignment operator. Okay, we declared it in the top. It is important to initialize the variable because the C variable only contains garbage values. When it is declared, we can also initialize a variable along with declaration. It initially holds garbage values. Okay, that's what they say. Mm-hmm. It is compulsory that the values assigned to the variable should be of the same type as specified in the declaration. Yes, it is. You cannot assign a floating point data to an integer type variable. Obviously, it will create a error. The data stored inside a C variable can be easily accessed by using the variable's name. Okay, changing strong values. We can also update the value of variable with a new value whenever we need by using the assignment operator. Mhm. So it will print number, it will print 25, it will print 30. How to use variables in the variables act as a name for memory locations that store some value. It is valid to use the variable wherever it is used. Wherever it is to use its value, it means that a variable name can be used anywhere as a substitute in place of the value it stores. Okay. So yeah, you can to print 60, you can, for example, a plus b expression that uses variables, expression that uses values. Right, nice. These are very basic things, but these are very important because if you did not study these at least once, you are not going to understand. You are not going to have the thought of ruling these things out. When a variable is declared, the compiler is told that the variable with a given name and type exists in the program, but no memory is allocated to it yet. Memory is allocated when the variable is defined. Most programming languages like C generally declare and define a variable in a single step. For example, in the above part, where we create a variable is declared and defined in a single statement. The size of the memory assigned for variables depend on the type of the variable. Size of operator. Operator. It is performing on an operand. Yes. Variables are also stored in different parts of the memory based on their storage classes. Yes, this is a good article. Alright, who's this guy Karthik? Is he Ayate Roorkee? Mm-hmm. Is he the person? Maybe teaching is his passion. Yep, I think that is that guy. Wait, did you kind of read this? Yes. I need operators now. Sandeep Jain. So he's Sandeep Jain, it seems. Yeah, he's that guy, right? Okay, by the way, this is my LinkedIn. It looks trash. Chaganti. All right. Operators are the basic components of a C programming. They are symbols that represent some kind of operation, such as mathematical, relational, bitwise, conditional, logical computations, which are to be performed on values or variables. The values and variables used with operators are called operands. Okay. Unary, binary, and ternary operators on the basis of the number of operands they work on. Operators can be classified into three ways. Unary operators are operators that work on single operand, increment and decrement. Binary operators that work on two operands, addition, subtraction, multiplication. Ternary operators that work on three operands, conditional operator or ternary operator. I mean, okay, so the original name for it is conditional operator. C language provides a wide range of built-in operators that can be classified into six types based on their functionality. Okay, arithmetic operator. Wow. What is plus A? A is 25. Okay, minus A and the negative of that number. Kind of like 2's complement. Nice. Why is A minus minus printing 26? Yes, I kind of need to execute this code. No, I need to execute this absolutely. Desktop. If we have any sort of explanation for that. No, we don't. Post increment and post decrement behavior. Oh god. Oh yeah. Nice. Relational operators are used for the comparison of two operands. All these operators are binary operators that return true or false values. The result of comparison. Hey, do we have any format specifier for printing a Boolean value? Do we have a specific format specifier for printing a Boolean value in C? There is no. Okay. Nice. Yep, there is no dedicated format specifier. Alright. Less than, equal to, and not equal to. Logical operators are used to combine two or more conditions or constraints or to complement the evaluation of the original condition in third consideration. The result of the operation of a logical operation is a Boolean value with a true or false, logical and logical or logical not. Bitwise operators are used to perform bit-level operations on the operands. The operators are first converted into bit level and then calculation is performed on the operands. Mathematical operations such as addition, subtraction, multiplication, etc. can be performed at the bit level for faster processing. Bitwise OR, bitwise XOR, bitwise first complement, bitwise left shift, and bitwise bitwise first complement. Assignment operators are used to assign value to a variable. The left side operand of the assignment operator is a variable, and the right side operand of the assignment operator is the value. The value on the right side must be of the same type as the variable on the left side, otherwise the compiler will lies in error. The assignment operator can be combined with some other operators in C to provide multiple operations using single operator. These operations are called compound operators. Addition, assign, minus, assign, multiply, assign, divide, assign, modulus, assign, and assign, or and assign, XOR and assign, right shift and assign, left shift and assign. I was not aware of these things actually. What is this double modulus? Is it correct? Yeah, it is just a printf statement wrong, I guess. Let's see. Size of operator. But it is a literal string, right? Yeah, it is obviously a compiler error, if I am not wrong. No, I need to check these things out. Right. This site is not responding. And now what? Wait, what? Why is that should be the most valid conclusion. It is because how printf works. Okay. Yep. Even though ChatGPT did not understand it, you have understood what you were thinking about. So what if you kind of do this? It will print it twice then? Yes, sir, it does. Apart from the above operators, there are some other operators available in C to perform some specific tasks. Some of them include size of is much used in C programming language. It is compiled in one try operator, which can be used to compute the size of its operand. The result of size of is the unsigned integral type, which is usually denoted by size underscore t. Basically, the size of operator is used to compute the size of the variable or data type. You can kind of say it as an operator. The comma operator represented by the token is a binary operator that evaluates its first operand and discards the rest. The result then evaluates the second operand and returns the value. Lowest precedence. Is a conditional operator that we can use in place of if else statements. If expression 1 is true, then we will execute and return the result of expression 2. Otherwise, the condition expression 1 is false. The dot and arrow operators, member operators, or operator. Casting operators convert one data type to another, for example. Typecasting operator. Address of and dereference operator. Address of operator returns the address of a variable, and the dereference operator is a pointer to a variable. Nice. These are referencing and dereferencing. Size of ampersand. Okay. This is dereferencing actually. So the first one gives a yes, and the second one gives a value. It is strongly recommended to an operator precedence and associativity after reading about operators. Yes, it is strongly, but we will follow the syllabus. Wow, you are about to complete C. Function is a named block of code that performs a specific task. A function can take inputs called parameters, execute a block of statements, and optionally return a result. A function allows you to write a piece of logic once and reuse it wherever needed in the program. This helps keep your code clean, organized, and easier to understand and manage. Right square function returns x times x, square of 5. Avoid repetition, easy debugging, simpler testing, readable code, modular design, team friendly. Nice. Return type function name parameter list body of the parameter list body of the function. Function return statement return type specifies the type of the value the function will return. Use the void if the function does not return anything. Function name a unique name that identifies the function. It allows the same name as the rules as variables. Parameter list is a set of inputs values are passed to the function, and the function takes no inputs. This can be left empty or written as void. Function body, the block of the code runs when the function is called. It is enclosed in curly braces. Function declaration versus definition. It is important to understand the difference between declaring a function and defining it. Both play different roles in how the compiler understands and uses your function. Function declaration. A function declaration tells the compiler about the function's name, return type, and parameters before it actually used. It does not contain the function body. This is often placed at the top of the program or in a header file. Function definition. The definition provides the actual implementation of the function. It includes the full code or logic that runs when the function is called. Why is declaration needed? If a function is declared after the main function or another function that uses it, then a declaration is needed before it is called. If a function is defined after the main function, in short, the declaration introduces the function the compiler. The definition explains what it actually does. Once a function is defined, you can use it by simply calling its name followed by parenthesis. In this example, the function add is called with values 5 and 3. The function runs its logic, adding the numbers and returns the result, which is then stored in the variable result. You can call a function as many times as needed from main or other functions. This ends up writing the same code multiple times and keeps your program clean and organized. In C programming, functions can be grouped into two main categories: library functions and user-defined functions. Based on how they handle input and output, user-defined functions can be classified into different types. Library functions, they are built-in functions provided by C and many others. You can use them by including the appropriate header file. User-defined functions, these are functions that you create yourself to perform specific tasks in your program. Depending on whether they take input or return a value, they can be classified into four types: no arguments, no return value, arguments, no return value, no arguments, return value. Alright, this is just two variables and there could be 2 possible combinations. Each type serves different purposes depending upon what the program needs. Use the right type helps you make your code more organized and efficient. Memory management in function. When a function is called, memory for its variables and other data is allocated in a separate block in a stack called a stack frame. The stack in which it is created is called function called stack. When the function completes its execution, its stack frame is deleted from the stack, freeing up the memory. Refer to this article to know more about function called stack. Each function call adds a small overhead due to memory handling and jumping between code and sections. For simple and short tasks, using functions can slightly reduce performance escaping, especially in loops. Heavy use of functions can make the program flow harder to trace across multiple locations. Too many small functions can lower readability if not organized or named properly. Local variables are limited to their function, making data sharing between functions more complex. Yep, the article is good. Alright. You completed this, right? Scope, pointers, enum, structure, and typecasting. The scope of a variable x in the region of the program in which the use of x refers to its declaration. Okay, the scope of a variable x in the region of the program in which the use of x refers to its declaration. Okay, that's a complex sentence. One of the basic reasons for scoping is to keep variables in different parts of the program distinct from one another, since there are only a small number of short variable names and programmers share habits about naming of variables. Example I for an array index in any program of moderate size, the same variable name will be used in multiple different scopes. Scoping is generally divided into two classes: static scoping, dynamic scoping. Okay, the author is more philosophical. Yes, Vinit Joshi. See, with the writing style, you can understand. I'm glad that I could be able to understand that static scoping is also called lexical scoping. In this scoping, a variable always refers to its top-level environment. This is a property of the program text and is unrelated to the runtime call stack. Okay. Static scoping also makes it much easier for to make a modular code as a programmer can figure out the scope just by looking at the code. In contrast, dynamic scope requires the programmer to anticipate all possible dynamic contexts. Philosophy. In most programming languages, including C, C++, and Java, variables are always statically or lexically scoped. Binding of a variable can be determined by program text and is independent of the runtime function called stack. Yes, based on the parenthesis, you can say that, for example, the output of the below program is 10, i.e. the value returned by f is not dependent on who is calling. So this is the scope. G, it returns x. G has its own variable. Okay, the function f returns x, and x is equal to 20, and it returns f. G declared some other x, but it is returning this x. The x is 10. To sum up, in static scoping, the compiler first checks in the current block, then in global variables, then in successively smaller scopes. With dynamic scoping, a global identifier refers to the identifier associated with the most recent environment and is uncommon in modern languages. In technical terms, this means that each identifier has a global stack of bindings and the occurrence of identifier is searched in the most recent binding. In simple terms, in dynamic scoping, the compiler first searches the current block and then successively all the calling functions. Okay, this is not at all related to C. He wants to. He went too deep. He just went too deep. What programming languages is dynamic scoping? Emacs, Lisp, Perl, Mathematica, Bash, older Lisp dialects, Python uses static or dynamic scoping. Lexical scoping. Perl and Emacs are right. It is not at all related to what we are studying right now. That is a good article, though. That is a good article. Maybe he is much into low level technologies. It is already 9. Pointers in C. A pointer is a variable that stores the memory address of another variable instead of holding a direct value. It holds the address where the value is stored in memory. It is the backbone of low level memory manipulation in C. A pointer is declared by specifying its data type and name with an asterisk before the name. Data type, pointer name. The data type indicates the type of variable the pointer can point to. For example, int pointer declares a pointer to an integer. Accessing the pointer directory will just give us the address that is stored in the pointer. To get the value and the address stored in the pointer, we use asterisk operator, which is called dereferencing operator in C. Note that we use asterisk for two different purposes in pointers. One is to declare a pointer variable, and the other is an operator to get the value stored at address stored in pointer. This is a single point that I have not understood until like the last 2 to 3 days. And this, without knowing this point, I have wrote the C programming language this semester. Variable 10 and a pointer is declared to the variable var, and you are printing, and it just returns the address in which the 10 value is stored. Address of the pointer variable. Okay, nice. So pointer to a pointer. Int ptr tptr as equals to ampersand ptr. Let's see. A pointer is initialized by sending the address of a variable by using the address operator. Initializing a pointer ensures it points to a valid memory location use. You can also initialize a pointer to null if it does not point to any variable yet. Dereference a pointer. Okay, so you need a backslash n over here. We have to first dereference the pointer to access the value present at the memory address. This is done with the help of dereferencing operator, same operator used in declaration. Okay. Here we use %d for printing pointers, %p for printing pointers. Right. Size of the pointer inside depends on the architecture of the machine, not the data type it points to. On a 32-bit system, all pointers typically occupy 4 bytes. On a 64-bit system, all pointers typically occupy 8 bytes. The size remains constant regardless of the data type. Okay. Nice, right? I have no idea regarding the size of pointers. The actual size of a pointer may vary depending on compiler and system architecture, but it is always uniform across all data types on the same system. The clarity was by assigning null value to the pointer. A pointer of any type can be assigned the null value. This allows to check whether the pointer is pointing to any valid memory location by checking if it is equal to null. Alright. If you kind of do this, will it give the address of the PTR some value? Yes, sir, it does. A void pointer and C are the pointers of type void. It means that they do not have any associated data type. They are also called generic pointers as they can point to any type and can be typecasted to any type. Yeah, a void pointer can be typecasted to an int pointer. That is what we have done in the threads. Wild pointers are the pointers that have not been initialized with something yet. These types of C pointers can cause problems in our programs and can eventually cause them to crash if values are updated. Using wild pointers they could cause data import or data corruption. Dangling pointer, a pointer pointing to a memory location that has been deleted or freed, is called a dangling pointer. Such a situation can lead to unexpected behavior in the program and also serve as a source of bugs in C programs. If allocated memory, you freed it. The pointer arithmetic refers to the arithmetic operations that can be performed on a pointer. It is slightly different from the ones that we generally use for mathematical calculations, as only a limited set of operations can be performed on pointers. These operations include increment or decrement, addition or subtraction of integer, subtracting two pointers of same type, comparing or assigning two pointers of same type, to comparing or assigning with null. If in constant pointer, the memory address stored inside the pointer is constant and cannot be modified once it is defined. It will always point to the same memory. Wow, you can create a constant pointer. It always points to A. Nice. As we try here to assign PTR to a new address, the compiler throws an error because a constant pointer cannot change the memory location it was originally assigned. We can also create a pointer to constant or even a constant pointer to a constant. No, like I can kind of understand it. So let's dereference it. Pointer to function. A function pointer is a type of pointer that stores the address of a function, allowing functions to be passed as arguments and invoked dynamically. It is useful in techniques such as callback functions, event-driven programs. It is a file function pointer, the signature of add function. Okay, okay. Where is this one? Dude, I legit coded it somewhere. I, dude, I wrote it right. No, trust me. Where did I write it? No goddamn clue. Right? So, okay. Something's wrong with this one, I guess. But no worries, we still have our own compiler. So, as this guy said, you can write a constant pointer ptr2 printf backslash n comma. So you need the value of ptr2. Initialization is a pointer from integer with a cast. So how do you initialize a pointer to a... Oh, that's why the error caused and it kind of bugged out, I guess. So how do you initialize a pointer to a literal? Segmentation fault. Oh yeah, maybe that's what the error is. No, that is not the error as well. Mhm. We made it. We kind of understood some pointers at least. That is something I can be proud about. 52 minutes it is. We will complete pointers and we will close this session. Pointer to a pointer. Pointer to a function. Okay, the signature function pointer, alright. Multi-level pointers. So you can create multi-level pointers with any number of levels. Double pointer, it stores the memory address of another pointer. Instead of pointing to the data value, they point to another pointer. Nice. Following are the major advantages of pointers in C. Pointers are used for dynamic memory allocation and deallocation. An array or a structure can be accessed efficiently with pointers. Pointers are useful for accessing memory locations. Pointers are used to form complex data structures such as linked lists, graphs, and trees. Pointers reduce the length of the program and its execution time as well. Pointers are vulnerable and have following disadvantages. Memory corruption can occur if an incorrect value is provided to pointers. Pointers are a little bit complex to understand. Pointers are majorly reasonable for memory leaks in the accessing using pointers are comparatively slower than variables in C. Uninitialized pointers might cause a segmentation fault. Okay, segmentation fault seems to be one of the most common and problematic faults in C. Enum, struct, and union typecasting. Nice, right? This is actually kind of enjoyable. That is enough, and